Hello, everybody. I'm also going to invite our distinguished panel onto the stage. If we could have, please, Chris from Astroscale, Dana from the Exploration Company, we have Max from VAST, and we have Jeffrey from Atmos Space. Please welcome our panelists to today's discussion. So I'm thrilled to be here with you today, and also thrilled to acknowledge this is Gadi, otherwise known as Sydney, the lands of the Gadigal people, and I pay my respects to elders past, present, and emerging in this amazing land we have here today. I'm thrilled to be with some of the leaders in one of the most exciting areas of space technology and social and engineering development, scientific development, and really a spirit of exploration. And today we're talking about a fundamental idea in sustainability, that is the circular economy, how we are going to create a self-sustaining economic model that also allows us to create systems that will last for many, many generations to come, preserving the commons and ensuring that the Earth orbit and the orbits around the Moon and Mars and beyond are things that we can continue to use and enjoy and benefit from for all humanity. It's a lot to take on, but the circular economy is a good thing to Google up. We're also going to have some questions. We're going to try and make sure we have a good chunk of time for you for questions. And we have a Slido system. I have an iPad in front of me, which will pop up some questions. And so really encourage you to think about the conversation we're having today. And if there's anything you're interested in us exploring at the end, we'll see if we can make time for it. And that'll come up in front of my iPad here. But we have a lot to get through. Really exciting things that we are seeing already. We're seeing that platforms like the Falcon 9 by SpaceX has really demonstrated the power of reusability, which is one of those core ideas within the circular economy, taking out massive amounts of cost, allowing them to really accelerate their then development of fully reusable platforms like Starship. And of course, we also have hot on their heels Rocket Lab, our neighbours from New Zealand, we like to say, who are building their Neutron fully reusable platform, and Blue Origin themselves, and a number of others who are looking to do fully reusable launch systems. What we also want to start talking about is how might we start reusing satellites? How might we extend their lives? How might we extend the lives of critical scientific infrastructure? Gosh, we're going to start having a lot more people, much more diverse kinds of people living in orbit with the work of folks like VAST, who we have here today, represented by Max. And what does that mean for a sustainable space economy? And I'm particularly excited to see how it inspires future generations and affects life here on Earth as well. So I'm going to dive straight into a first question that I've set up for all of our speakers. And Chris, I'm going to lead with you. Chris, COO at Astroscale, headquartered in Tokyo. An amazing business vision you have to reboost, to inspect, to remove debris, to do all sorts of things around logistics in orbit. I noticed the recent contract that NASA just awarded to boost the SWIFT telescope, which is a really exciting thing that's come out, and also a recent UK Space Agency proposal for debris mitigation. We're starting to see the first signs of interest in the services in orbit. Can you tell us a little bit about Astroscale and your first milestone, the thing you're working for today?
Well, thank you, Tim, and thanks to my fellow panelists for being here. This is a fundamental topic, as you said, this idea of a circular economy in orbit. And we are really excited about the advent of the on-orbit servicing sector. Because all of us in this room, all of us here in Sydney this week, hear about this multi-trillion-dollar orbital economy that's coming. We all recognize that this is what we're aiming for. That's not going to happen without a mature, without a safe, without a reliable on-orbit servicing sector. We see reusability happening, as you mentioned, Tim, right now with launch, but we need to start seeing that happening in orbit as well. And what does an on-orbit servicing sector entail? It's around the things that Astroscale is driving, but also around other companies. There's dozens of companies around the world right now that are focused on developing these technologies. And that technology proof is happening. And those demand signals are happening. You talked about the SWIFT mission, the UK mission. We in the Japan office for Astroscale are actively doing an inspection mission of an upper stage rocket body, non-cooperative, non-communicative approach. So all of that is what's so exciting about the sector writ large. As for Astroscale, to be clear from the start, we are not a debris removal company. That is something that I think a lot of people might say that we are, but the fact is we're much larger than that. Debris removal is a part of what we do, but we're looking at all aspects of on-orbit servicing. As for the missions that we have ongoing, we have the one that's in orbit right now, Address J, which is doing a close-up inspection of that JAXA upper stage rocket body. Then we've got a variety of missions across the board in our entities around the world. Japan, UK, France, and the US are P&L responsible entities around the world. We also have an office in Israel that's working with our US team. In each of those offices, we have missions ongoing. Our next one's going to be next year with our US office doing a mission with the Space Force on refueling. So there's another aspect of in-orbit servicing that we're focused on. And I'll close by saying the technology around this is what is common. And that technology is around RPO and docking. Rendezvous and proxops and docking with an object in orbit is going to open up the aperture for all aspects of on-orbit servicing and is going to make that trillion-dollar, multi-trillion-dollar ecosystem in space possible. Thank you.
Thank you, Chris. Wow, that's exciting. I love hearing things like remote operations on a panel in orbit. Next, Dana, I'd love to hear more about another company with an amazing, cool name, the Exploration Company, who are doing remarkable things already with re-entry vehicles, but you've got much more sort of exciting things to talk about. Tell us a little bit more about the Exploration Company.
Thanks so much for having me here today. I'm very happy to be talking about the Exploration Company with all of you. We are a Europe-based company that's now also in the US and in the Middle East, in the UAE. And we're really focused on everything space transportation. So we started with a re-entry vehicle and a capsule now called NEEX that will be taking cargo up to the ISS and later to all of the CLDs out there. And our first mission there will be in 2028, docking to the ISS. But that vehicle will also then be crew rated. Our second vertical is really around the moon. So we're building lunar landers. And the third is around launcher. So we're building our own reusable launcher. So with that comes a lot of different types of propulsion, from cryogenic propulsion to a large, Raptor-like high thrust engine. So we have our fingers in everything that's around space transportation. And circularity is really important to each part of that. It's the reason why we are getting into each and every one of them, because we realize how interconnected they need to be, and how building a modular system can really help build scale across all three. So as far as milestone is concerned, I think that was your question. For NEEX, we are going to be going through CDR next year and second phase of safety review with NASA so that we can fly in time in 2028. We'll be doing an on-ground demonstration of our lunar lander in early 2027 in the UAE, and we have some big milestones for our propulsion next year. So, look out for those. We'll usually post those online so that everyone can see what we're doing there.
So not only in orbit, but cislunar coming up into the economic sphere. Super exciting. Max, you founded VAST to really revolutionize human presence in space, I understand, and thank you so much for all the work that your team have been doing so far at IAC. Your stand is gorgeous and everyone is loving visiting it. The company, your vision, what's the next major milestone you're thinking about, you're working towards in this framework?
Firstly, a correction. I'm the CEO at VAST, and the founder is Jed McCaleb, also our main and investor that has allowed all of this to be created. And hopefully, people will love more our space station than our booth. But thanks, thanks for regarding the booth. So VAST is a space station company, and if you take the topic of the panel, the circular low Earth orbit economy, no one has yet created a commercial human-rated platform in low Earth orbit. We obviously have the AEST, and we also have in China the Tiangong space station, and there's a need to transition to a commercial platform. That transition actually started with the transition from the space shuttle to the Dragon spacecraft of SpaceX. Without that transition to go from a cost-plus contract to fixed firm price, and the ability for us to buy a Dragon spacecraft to bring crew to our future destination, we would not even exist. So the transition started, and you can already see the circular aspect. The creation of Dragon allows companies like VAST to exist. Now, in terms of next milestone, we need to work with governments around the world, starting with NASA and all the existing ISS partner. And today there is a competition called the Commercial LEO Destination Phase 2 competition that has been accelerated and is due to be awarded as early as March next year, where NASA will pick 2 companies or more to start building and developing the successor to the ISS that is commercial. So the milestone for us there is that we really will be applying, and obviously are a hopeful winner of that competition. In terms of hardware, which is what's most differentiating and most important for VAST, we have 2 upcoming milestones. The first one is our first demonstration satellite. It's not a crewed system, it's a 500-kilogram satellite with all of our avionics, propulsion, and other systems. As shipped to our launch site, actually last week, and was obviously fully integrated and tested for a launch later this year. So we're very excited to have the result of that mission and obviously demonstrate that to our future partner. And then more importantly, VAST has been building Haven 1, what we expect will be the world's first commercial space station, due to launch next year. And we have reached a point where we have completed the welding of the flight primary structure. We're about to do the proof testing and start integration for launch next year. And that space station is fully funded, including the flight with SpaceX to bring a crew of 4 for a 2-week mission and back home safely, irregardless of the CLD competition. So it's one of the key value of VAST, which has been, let's not wait to have NASA as a customer or as a funder. Let's go for it. Let's use private funding at 100% level, and let's build an actual space station that can have crew mission and also payloads, which we have five payload partners that we can talk about later. So that's the next 2 milestone, demo launch and winning, hopefully CLD and launching Haven 1. So a busy year coming up for VAST.
Thank you so much, Max. I'll demote you from founder, but thanks for that top. Jeffrey, welcome to Sydney. It's fantastic to have you here. You're super experienced, having done over 7 missions and so many more payloads and so forth in your career. Now with Atmos Space, am I pronouncing that correctly?
It's correct, yeah.
Excellent. And you are also looking at the logistics kind of last mile and also return from orbit. Tell us what you guys are working on right now and a little bit about the company.
Yeah, so you're right. We're basically a logistic company, and within the whole circular economy chain and the logistics chain, we are focusing on the last part, from LEO back to Earth. And that said, it's of course with that we focus then on free flyer platforms to support the Earth-based pharmaceuticals, semiconductor, bio, and pharma, to give our customers access to microgravity, but with small packages. So we talk about like a 100-kilogram type of payload, but with a repeatable flight. With that, we just recently flew our first capsule, the Phoenix 1. This is I call it as a Phoenix as a payload version. And we have a 3-stage step there. So with Phoenix 1 test flight done, we go now already with the Phoenix 2, with a milestone for a flight near the end of 2026. And that's a full free flyer platform. Still the same amount, 100-kilogram free flyer platform to provide microgravity access for our customers. The next stage is Phoenix 3. which is just for a 1,000 type of free flyer capsule. But the same logistics. So we would like to launch from multiple places in the world, of course. We have a focus on launching from Europe and landing in Europe, which is the Azores. I'm here in Australia to look how to launch here and land in Australia. And of course, we are having our partner with SpaceX, which we will launch the Phoenix 2 with. And for that one, we'll try also to find a nice launch place, which should be also the Azores. With that said, we have also a long-term goal, which is for the down mass in the logistics chain. I'm looking for down mass needs from our partners here, from the space station, but also from space exploration company, because we see the need that not only a larger amount of equipment has to come back, because you want to build a lot of things, but things has to come back. It doesn't always fit into a cargo hold. And I recently came from a conference related to the effects of re-entry vehicles and re-entry like demise. It looks like we're not always allowed to burn up everything in the atmosphere. So that's another step we would like to explore further. I hope I answered the question.
Thank you so much. No, it's super interesting, and I like the names of the spacecraft. Phoenix seems appropriate to a circular economy model as well. Thank you very much. So we're going to turn our attention now to one of the core drivers of the flywheel of any business model, which of course is demand. And all of you are pioneering companies because you are all slightly ahead of demand. The demand signals are coming from, in some cases, government and exploration programs, but we anticipate that demand to become more and more privatized and perhaps more imbricated into the more wider economy, other industries and so forth. Infrastructure is another word that keeps coming up. In preparing for this panel, we were talking about this yesterday. Jeffrey used the word, what's the real estate that we need to create in orbit? Because we're always in this frontier mode, needing to go to a place of infrastructure and a piece of real estate to deliver to that infrastructure. So, Chris, starting with you, demand signals that you're seeing, how do you think this is going to play out over the next few years? What's your view?
Yeah, that's always the tough question in an economy like space and with startups like ours, is driving that demand. And how much are we responding to, and how much are we creating that demand? And at Astroscale, when we were founded in 2013, we knew from the start that we'd have to be more on pushing the creation of the demand. We as a community know that this is an issue, that there's so many more objects going to orbit, that we are so much more reliant on space for everything we do, that there's going to have to be something to address these issues of security and sustainability in space. So it's an odd thing, because the recognition of the need for what we do is there. The demand to pay for it has been a bit slower. And so what we see happening now is we see a steady increase in interest, primarily from governments, primarily from a lot of defense demand around the capabilities that we can provide, but also a lot of civil government demand. There's a growing recognition that the way that we're going to create this ecosystem, the way that we're going to build this space superhighway, this space neighborhood, which is actually better than the superhighway, because I think we're building a space neighborhood with a bunch of different types of capabilities in orbit. But the way we're going to get there is not through commercial demand in the near term. It's going to be through a lot of government investment. And that's the case in space writ large, right? We all know that. And so what we see happening is that the demand drivers are appearing over the last 5 to 7 years particularly, and only increasing as well. And that's spurring on more players. We've got a lot more competition than we did when we were founded 12 years ago, which is a good thing. It shows that the market is increasing. And the way we see it happening is that this continued government demand, civil and defense, is going to allow us to prove out capabilities. It's going to allow us to get better at building what we're building, get more efficient in our manufacturing, likely reduce costs of manufacturing. And then the more that we can get a viable price point to the commercial customer, the more that we can show that our capabilities are reliable and safe, then we're going to start seeing interest. Because the interest around servicing, it's going to create value. It's going to create value by extending the lives of satellites. It's going to create value by reducing risks in orbit. It's going to create value by refueling objects in orbit, by making sure we're able to monitor threats. All of this is value creation for the industry writ large. But we're relying on government partners to make sure we get to that point that the commercial sector buys into it as well. And it's going to take all of us working together also across sectors of this circular economy to make that viable also.
And there's a lot of changes happening out there with this explosion of constellations, and most of those satellites not designed to be refueled yet and so forth. So there's a huge upside perhaps in the medium term as that transforms. Dana, I am very intrigued by your thoughts on this question. We're in this very fascinating transformation from fully government-led, 100% in-house, inside JPL or inside JAXA, to now this partially outsourced model. Is that a wave you're surfing?
Absolutely. I mean, with most companies, we have government as our anchor clients. Like, we are completely privately funded, but a big part of being able to do that was by securing government contracts from that standpoint. So I think, like many things in the industry, the original demand does come from government. That being said, that demand helps spur the innovation that brings together the rest of the innovation that can come from the commercial industry. So we are serving, the European Space Agency's demand to take cargo up to the ISS, but then our future missions will be to the VAST station and whatever other stations are up there. So it will go from government to private. And I think, what we've seen from our missions so far, so we've had 2 missions so far, and we have our 3rd one coming in 2028. They're all sold out. So you think it's sort of like, if you build it, they will come. Once you start building something that you can show, hardware you can show, a product that you can sell, there's obviously hard work in educating the market, but once you do that, you'll realize that there is actually a lot of innovation coming. I mean, before SpaceX started, I don't think people were saying, "Oh, we really need this," and there's a huge market for it. But now that it's built, it's several years out to be able to get a launch, right? So I think that it's going to be the same across the board. Once you're actually up there, you will have a lot of others that see the benefit of what can be done in space.
Fantastic. And Max, we're hanging a lot on this commercial LEO destination to replace the ISS, but listening to you, I can hear you're not actually relying on it. You believe, perhaps, is it true that there's enough demand across all these different areas that you can build a piece of real estate in space, and you can take people there, you can take robots there, you can get really valuable things from that microgravity environment? Is that how you're thinking of demand?
No, we reframe it in a totally different way. The first step is actually not creating demand, it's cutting cost. And what's driving the transition to the ISS? It's obviously the geopolitical aspect of the partnership with Asia, the aging, leaks and so on. But then the main driver is NASA wants to go from $3 billion a year to $1 billion or so. So they want to do at least the same amount, maybe more, with materially less. That creates an opportunity. And if you look at the transition from the space shuttle to the Dragon spacecraft, the cost per seat for NASA to send a crew member to the ISS has gone at least 10 times lower, maybe 50 times lower by different metrics of accounting for the space shuttle. That did not come from demand. Actually, only recently has SpaceX managed to sell Dragon to other people. It came from creating the incentive of a fixed firm price contract and incredible execution to do it at a much lower cost. And so that's the first step for VAST, right? Is accomplishing that mission for NASA and other government by lowering the cost materially through execution, right? Not through new customers. Once we're there, our view in our business model, we believe we can be profitable with the existing market. So all the existing governments that are involved in the ISS, emerging one, and NASA, while still reducing the cost, in an unprecedented way for them. Once you get there, a profitable company that has a platform, then you have the opportunity to unlock the new demand, but we don't rely on it. And obviously that's based on physics. There's a lot of hope that we'll be able to do manufacturing of organs, semiconductor, obviously pharmaceutical, sponsorship and media. All these new things will be open to us, but we don't know if it'll take 2 years, 5 years, and we need them to become, billion-dollar-a-year opportunities. And so if you're profitable on the current market, you'll get to basically unlock that other market if anyone does it. And that's really, that's our view, but we believe that any commercial platform should not be dependent on it. Because if it doesn't arrive on time, then the government needs to bail you out, right? And so they should make sure they choose companies that are low cost before just believing the new demand, PowerPoint slide or business model section of a proposal, basically.
I love that idea. We're taking out the friction from this flywheel of this circular economy to really bring in people because they can now afford to do many more new things. So thank you so much. That's such a great mental picture to hold into our minds as our audience thinks through the questions that I can already see them sending through. Thank you. Jeffrey, thinking about what you're hoping for, right? You have potentially a big customer sitting right next to you in Max. You have also other players that are emerging in this space. You are an earlier stage company, and so you've got a little bit more wiggle room. How are you seeing? What are the things that you have to do? Do you have to be super agile to figure out where the demand's going to emerge, or what's your internal narrative on that?
Actually, we're created due to a demand. Because of the terrestrial market, they see a need of creating their products in microgravity. Honestly, when we started Atmos, it was not about microgravity. It was about returning stages and upper stages and first stages. But with talking with the investors, we have a very wise group of investors. They kind of nudged us in this direction. Say, hey, there is a terrestrial demand. Have a look at that first. So that's what we did, and so I said, okay, let's make such a capsule, and we are then in the niche of the down mass, but a particular down mass for this microgravity part is also the need that the terrestrial market, they want to have a short, lead time. They want to have 3 months. They say, hey, I want to fly this 3 months from now. And that's why we do small packages, and we look at smaller rockets, and so it's a particular niche.
Yeah, that's super interesting. So I really like that niche aspect you've got. So we've got a very big and powerful and ambitious build it and they will come model, and that's very, very brave and exciting. And then you've also got this much more startup, right? Going to do it small, going to do it fast. Certainly another company in this space who are landing here in Australia and about to do their third landing, Vada, they talk quite a lot. I'm staying with you, Jeff. They talk quite a lot about this idea that the more they fly, the more they make, right? In other words, they move the big upfront CapEx, they move it as fast as they can into just OpEx, because the more they fly, the more materials that they create and can sell and so forth. Are you thinking about things the same way as well?
Yes, because the customers we have been approached by, for them it's production, so you need to fly more. So you either fly more of a smaller capsule, or you fly a little bit more of a slightly larger capsule. But it remains there the same. They need to create their product, and they need to get it back fast, soon. Yeah.
Fantastic. Max, you have the opportunity to go quite far beyond the ISS in terms of the things that you can do, right? You can rethink it, you can rethink the platform. What are some of the new areas you are excited about? On your stand, there's certainly a big push to say we're going to be able to take much more regular folks, not necessarily highly trained astronauts, to space. What are some of the other areas that you guys are excited about that go beyond where the ISS has gone in terms of that economy?
Yeah, I mean, the first opportunity is that if you look at the ISS, which obviously has been an incredible platform hosting humans in space continuously for more than 2 decades. One of the issues is that it's all laced into government restrictions and government approvals of what you can do there. The other part is that there is a a process to get your payload there, your experiment, if you're a pharmaceutical company or a brand or anyone. And there's no real capitalist way to accelerate it. It's like a fair first come first serve type game, and then follow all the rules. On a commercial platform, if somebody comes to us and say, I need a whole module to be built to be a factory in space, or I need 4 racks or something like that, and they're willing to pay for it, they're willing to skip the line or accelerate, we will be able to say yes. More importantly, we also don't have all these restrictions, right? We follow the laws of our land, the United States. We also have a brand and ethics, in terms of what people can do and what we can do with brands and what type of pharmaceutical or manufacturing we can do. But having seen the type of restrictions that the ISS has built up over the years, for all really good reasons, taxpayers paid for all of this, ours will probably be 1% of that, and they will be all focused on safety, right? For safety, we have to continue that heritage. But for everything else, we don't have the same consideration. And so that's part of what everybody is excited about, what will happen when a commercial crude microgravity platform will exist. It's not been done, it doesn't exist. We hope to be the first. So that's really the key difference there is, full capitalism, full lack of restriction. We own it, and then we'll see what happens with these customers.
Thank you so much. That's so awesome. I'd love everyone to have that in their imagination. What might we be able to do with these commercial LEO destinations? And that word destination, a really important part of it. Dana, you talked a little bit about your lunar aspirations. To what extent does the lunar economy and some of these other elements, even talking about going to Mars, to what extent is that something that you guys are focused on as an exploration company?
The lunar has always been a part of the vision. When the exploration company was started, we said, the capsule will be the first product, but we need to get started on lunar as well. So we started working on our cryogenic propulsion from day one. So it's always been a part of that, and we've come a long way from a propulsion standpoint. Now it's about building the vehicle and starting to build the vehicle. So we're going to be doing an on-ground demonstration of the landing and hopping. So ultimately, we want our lander to hop on the surface of the moon to enable rovers to be able to do much more on the surface. So I would say, our number one priority is ensuring that we deliver the capsule on time. We need to get to ISS before it's retired, and we need to be able to serve the demand. So I would say from a priority standpoint, our capsule is number one, but the moon is a big part of our vision as well. I think, we view space as something that's going to continue to be a frontier that we push as humanity. We're always looking to discover and see what's out there. And I think the moon is so pivotal in so much, from a landscape perspective that I think we definitely want to be one of the key players there.
Very exciting. And just staying with you for a second, the circular economy aspect of the moon, how are you seeing that evolve?
So it's interesting because there's some, there's landers out there, many that have already done it and others that are planned. But what we can serve is return from the moon, which is, whether we do it from our own lander or whether we serve others, that's a big part of the circular economy, because we're going to be doing a lot of different things on the moon. There's a lot of science that can take place, but then we need to bring it back here on Earth. And I think that's something pretty unique that we would offer into the ecosystem, and that will be really, really important as a part of the circular economy. I think another big piece is some of the cryogenic refueling work that's underway. Us and others, we're working on it, but a lot of the different players are going to be using cryogenic propellant. And in order for us to get to Mars or to even do more on the moon, that refueling will be quite important, and I think a big part of ensuring circularity. So I think we're just at the beginning of what's possible from a lunar economy standpoint, but I think it's going to be a big part of making it successful.
Thank you so much. That's exciting. So Chris, we brought these folks together. Astroscale has been a very early mover in this space. You've sort of set some of the language. You've also had a fantastic partner in the Japanese government and JAXA who are quite forward-thinking in this area. things like regulation, things like interoperability, modularity. How are you seeing these circular economy elements coming in? And you know, I guess in some cases they act as a moat to create it, make it a little bit more difficult for people to join. At the same time, you want it to kind of power scale. Like, how are you seeing that aspect of what you've been doing?
Yeah, it's a great point. And from the start, regulation was a key part of what we wanted to focus on. And some of our early mission language was around the fact that we were going to focus on building the technology, articulating the business case, and focusing on the policy and regulation. It was a need for all three of those things to work together for us to be successful and for the servicing ecosystem writ large to work. And so along those lines, we've been very active in work with international groups, industry groups. I was very active and led Confers, which was an initially US-based industry group around satellite servicing and developing standards and best practices for that, with the recognition that we need as a community to get to some standardization if we're going to have commercialization. You can't look at really too many ecosystems terrestrially out there that don't have some standards in order to have a commercialized business focus. So that's always been a big part of what we do, and we're still involved in areas like the UN or World Economic Forum to help drive a lot of that excuse me, conversation. But also it's a domestic thing. You know, so much of what we're doing, as we're all saying, is government investment into these capabilities, and each country has their own regulation, their own requirements. And so one of the complicated things that we have to work on, and I think all of us have to work through, is synthesizing those. And we have these 5 entities around the world. A big part of it is allowing those entities to have some capability to service their local customer, while at the same time finding efficiencies just across astroscale on technologies and policies, never mind the entire ecosystem. But if we're going to really get to that level of a circular economy, something that does drive down prices for users, something that does allow for a more sustainable and secure orbit that we're working in, whether it's LEO, GEO, cislunar, we better get to levels of commonality around these issues.
I want to give you a glass of water as well.
What a great moderator, man. I got to use Tim.
That's important. That's important. Now we've cracked on. We've gotten some time here. We've got about 20 minutes for you, audience, and we've got some fun questions. And we can almost do this a little bit like a game show. We can have like a quick fire response. So I love this first one that we've come through on the Slido platform. Keep them coming though, folks. So this is a great one. If you could, Jeffrey, I'm going to start with you, and we'll come back through the group. If you could click your fingers and solve one technical challenge today, what would that be and why? And you're not allowed to overthink it.
There will be there's like several popping up. So there's well, the technical challenge I'm doing now is return. It's a real technical challenge, and not just return with ablative but something reusable. Which we can do over and over again, like an aircraft going from point A to B and back again without rebuilding the aircraft. Right? So that's it.
That's beautiful, because we don't want to be doing circular economy and creating all this extra waste in the upper atmosphere, right? We want to be able to have clean systems working, right? Max?
Probably AI-enabled design. You know, with none of us, I think, are yet designing, you know, mechanical interface, electrical system. It's a little bit of software, but obviously you have to be very careful, especially with human-rated software. So we're still, you know, using it for business, but not yet for designing better spacecraft faster. But that will come, right? Is it in a year? Is it in 10 years? We will see. And that will be a big change for all of us. So that I think if that was there today, it would be a whole new level for our industry and the world, obviously. So,
fantastic. AI thinking in 3D, thinking about model-based engineering, etc. Yeah, I know a few people who are working on that. Dana?
I would be human-rated. It takes a lot of work to go from cargo to crew for good reason. But I mean, those years would save a lot of time if we could do it at the snap of a finger.
Fantastic. Chris?
I think autonomous operations. It's something that we focused on in our first missions. As we get closer to a client in orbit, we need to work autonomously, but we need to do that across multiple missions. And we were still very human heavy in our operations of our first couple of missions. We need to get to the point where we can use AI and we can do that autonomously across dozens of missions ongoing.
Beautiful, and I've got a segue question from the audience. Thank you. I think Hugo, I owe you $5. What's the biggest blocker for RPO, remote proximity and operations, currently? And is it sensors, know-how, legal constraints? What do you think is the biggest blocker? We'll go from you, Chris, back down the line.
I really think it's more of the economic or the regulatory. We're solving the technical side, and again, we've already done RPO to a communicative object has happened for decades. What we're talking about is RPO to a non-communicative, and also doing it at a lower price point, and we're doing that. The technical side, the toughest part is going to be the business side, I think, and making sure that we're able to work together across entities, across countries to drive the ecosystem in that way, regulatory, economically.
Okay, Donna.
I mean, for proximity ops, I think there's doing it for satellites and other pieces, but I think the part that gets complex or more complex is when humans are involved, and you're talking about the ISS or a commercial LEO destination or other places. You know, there's a lot more at risk from that standpoint, and so I would say that that's probably the most complicated part, is ensuring that you have everything from a technical standpoint, but also from a safety standpoint. And right now that needs to be certified by NASA, which obviously adds a lot more regulation to it. So I think that's probably the biggest challenge.
Yeah, as Dana mentioned, you know, on our side, it's docking and berthing. You know, we have two standards in our industry for human docking and berthing, CBM for berthing that the ISS use in some cargo vehicle, and IDA or IDSS for the docking that Dragon, Starliner use. I think Starship will use for Orion. And obviously the ISS has. And so what we need is, there are standards, but the actual, you know, if you want to buy this hardware, you can't really do it. You know, only SpaceX and Boeing, I think, have done it successfully. Others are trying. And not only that, we need to make bigger docking interface. You know, the current one is not really adequate for a vehicle the size of Starship. So if we want to build bigger structure, bigger space stations, we need larger, you know, I'm talking about 3 meter instead of 1 meter diameter docking interface that will be able to accommodate a Starship. So hopefully we'll be part of making these industry standards, and we'll see you know, more innovation in docking interface for all of us.
Basically, I agree. It is regulatory, it's technology, and standardization. For us, we are a cargo company, so in the chain of circular economy, at some point we'll be shipping containers from LEO to Earth, and that requires a standardization, because it has to fly with ships from astroscale or from space exploration. It has to be able to dock to VAST. So that's it.
All right, excellent. Well, look, we're all trained up. We're now going to get to some of the more curly questions, I think, that are going to be fun to ask. Some of them are for the whole panel. Some of them are targeted to a few of the individual panel. So I think there's some fun aspirational ones. So I think I'll start, Max. There's a really interesting question here, which is around when are people going to be able to buy a ticket to come to a vast space station? What do you think? How soon do you think that might happen?
Well, and actually that touched on your comment. So unexpectedly, we don't believe in space tourism today. And so you've seen that our space station has a certain level of design, but that's because we believe that if you're a professional astronaut or a private individual, you do a space mission, every minute of your time count, and you should be doing experiment and research that either benefits space exploration or Earth, whether you are a billionaire that paid for it yourself or you work for a government. So the reason we apply high design is that if you feel better, if you sleep better, if you communicate better, then you're going to work better the next day. Just like on Earth, if you have a nice hotel room before you go to work, or a really bad one, it's going to make a difference. So that's why we do it. If you look at the evolution of human spaceflight and human space exploration, today we're in the early days of less than 700 people have gone to space. If you look at the aggregate time that humanity has had humans in space to do research, it's too small. So we first need to grow this research phase, having more people that have more opportunity to go to space, but to do important research. I think the next phase, hopefully with Mars and the Moon, will be people going to space to work, like maybe funding their own flight through committing to work. And we need these people to do their work, to build all the infrastructure on the Moon, on Mars, all the space station, so that eventually we will have the recreation, right? We will have people that they've worked in space, now they need to relax in a space hotel, or they want to do it from Earth. But that's a few decades away at least, because we really believe we need that work phase in between, and we definitely need to scale the research phase today. Having said that, we are selling to private individuals that are interested to do a space mission, but none of them are called tourists. We don't call them tourists. They don't want to be called tourists. And the training and activity they do are the same that a professional astronaut would do. The only difference is they can curate more which organization they work with and what experiment they do, instead of being told what they are, but they are using all of their time awake to do the same type of work.
Thank you, Max. That's great. Dana, curly question for you. So you've had some wins, you've had a few losses. What caused the loss of the Mission Possible reentry demonstrator? That was the question, and I don't know if it was a loss for you, but that was the question.
So, I don't think we would qualify it as a loss. I think we learned there was a lot of successful parts to the Mission Possible mission. I think the last part of the mission we're still investigating. So we have an external investigation board that's kind of checking what happened in the last moments of the mission that didn't let us retrieve the capsule. But we orbited the Earth 3 times, re-entered, and the pair. There was at the end there was a problem that made it so that the parachutes didn't open, and we weren't able to retrieve the capsule. But a lot was still learned from it. So I think we would qualify it as a partial success. As I would say, I think space is hard, and we have to learn from our failures. So I think we will learn a lot from Mission Possible. We'll publish what we learned from it, so that everyone else can learn from what we are experiencing right now, and then build it into our next steps. But more to come on that in the coming months.
Thank you so much for handling that so graciously. It was a tricky one. Chris, you've got a unique perspective. I have had the joy and pleasure and privilege of living in Japan as well, so you'll get this perspective. A few nations occupy 95% of the orbits. Should we consider a global tax on commercial space activities to fund equitable space access for developing countries, which is one of those aspects of circular economy?
That's a tough word, tax. The curly question is a tough one too. Yes. I like that. I always like to learn new Australian English. That's not something that we're really focused on. One of the things we have to be aware of is that all of us in the commercial sector are startups. We all have a runway. Even though we're at various levels of success, we all have a runway. And we're all trying to innovate and develop this ecosystem. Like Dana just talked about, we all have failures. We all have setbacks. And we have to be able to allow those to happen to make sure that this works. And so when we talk about having tax, that it gets into this level of potentially hurting innovation and restricting what companies can do to take these steps that we know we all need to take. We all need to take those risks and try to fail. And I know, looking at all of us, looking at our balance sheets, we know that we have to be really careful on this. And if you start implementing that T word, it's going to get really tough to do it. So now that doesn't excuse the fact that we need to think of something. And so that's a way that we like to work on regulatory and policy activities to figure out what is it that's going to help drive the creation of this economy in a more sustainable manner. And that is something that has to be addressed. But we have to talk around about what exactly is the right way to do it.
And the comment on tax, I mean, obviously in GEO we have more limited resource, but in LEO, is it really a zero-sum game? You know, we've gone from 4,000 active satellite to where we over 10,000 now. Can we go to 1 million? Can you go to 100,000? You know, is there really a limit? Because the tax implies that there is a limit. So it's something to think about here.
Yeah, maybe too early, but it's a good question thinking within this sustainability framework. Jeffrey, we would like you to be landing in Australia. What do we have to do? Who do we have to bribe to get you to switch to Australia from the Azores?
Approach me after this panel. Okay. Honestly, to land here, I love to launch from here. That's it. And there's a whole circular type of economy involved in that, which has to do locally and inside the nation. And yeah, we can elaborate it on a little bit more. So anyone who wants to join that discussion, see you afterwards.
Okay, so curly question. Well, you're all going to get the same question this time. So I'll stick with you, Jeffrey, and then we'll come down the line. So could you please explain how your company, or anyone can jump in at this stage, I think, if you really feel strongly about it. Can you please explain how your company is meeting these circular economy goals on Earth with your manufacturing and research development waste and your activities?
Oh, it's a good question, and I wish there was one way to answer that, but yes, as a company, normal terrestrial company, you have to follow rules and guidelines to be in a way already a little bit circular with what you use, what material you use, what you do with your waste. And basically what we're doing with our capsules is we're looking at the aircraft industry and automotive and implementing these ideas as well, which is also a bit about circular and waste and so forth. Now, spacecraft doesn't have as much as rules and regulations yet, like in the aircraft industry, but it will come. It will come, we know this. So we are trying to be ahead and be sure that our crafts can be reflyable, reusable. That's the same also for space exploration company. We have both a lot of work on that, and that's where it starts. I hope I answered it.
Thank you.
Yeah.
Max?
Yeah, I mean, that's a kind of a trick question. You know, if you look at, firstly, space companies or fall into industrial companies, and I don't think any of us are doing anything, you know, different or worse than industrial manufacturing and design. But more importantly, if you look at the size of the total global economy, and you look at how much is invested in terms of the people working and the company's value or the company's investment in space exploration, you know, you're talking about 0.00001% of global resource. I would argue, and obviously that, you know, any industrial activity will have some sort of waste, some sort of issue there, some better than other. Sometimes that argument would lead to we should do less space and save the Earth, and that doesn't make a lot of sense. I think if you were the CEO of the Earth, you would say maybe it's reasonable to invest 1% of resource in making sure we explore the stars and making sure we maybe have a backup, right? 1%, and that's an industry that would be probably, you know, I can check all the numbers, you know, go on ChatGPT, but at least 1,000 times bigger than the aggregate number of people industrial activity for space exploration. So we need to not, you look at that and say, oh, we should go to 0% because we feel guilty. We need to obviously be responsible and do everything that are best practice in any industry. But we should also scale the global effort in space exploration if we are responsible global CEO as a thought experiment. So,
I guess the hope is sustainable manufacturing is also more efficient, lower cost, all those things you were driving. That's a hope that we have. But yeah, thank you. Any other want to have a go?
Yeah. I think this is something we've tried to really pioneer for the industry because not much has been done from that front. So we actually set up a team to measure our footprint and to start doing life cycle assessment for each one of our projects, and we're working closely with institutions on that so that everyone can kind of learn from what we're learning from, because it hasn't been done at all or in many places yet. And we also have engaged B Corp. So I'm very proud to say we're B Corp certified. We're one of 2, I believe, space companies that are B Corp certified now. So something that we are going to have to ensure that we show that we're, not only are we certified now, but we are improving along many metrics there. So it's something that we've always said is very important to us, and we're trying to hold ourselves to that standard.
And I'd say for us, it's still nascent. We know we have to address it, and we also set up teams to do an ESG assessment of where we stood, what our footprint was in each of our 5 different offices. To Max's point, we're not really manufacturing too much just yet, but we do want to be aware of it. One thing I say that we are doing that's a little different than this is studying the environmental effects of reentry. We have teams that are looking at what it does to the atmosphere to bring back upper stage rocket bodies, to bring back debris. We know that there's pieces of debris coming in every day and burning up in the atmosphere. We don't know yet what the larger term impact of that is. And if we do what we're saying we're going to do with our next mission in Japan, address J2, we're going to be bringing back an upper stage rocket body. It's going to have some potentially environmental impact. We want to start understanding that better. And what we want to do then, tying back into the theme of this whole discussion, we want to be able to do more in orbit so we don't have to bring stuff back into the atmosphere and risk that environmental impact. We want to be able to do that manufacturing, that those capabilities in orbit. And when you look forward into the next 10, 20 years, what we could see is maybe less launches, maybe less satellites built here, maybe more capture of a debris object and bring it to a space station. We're already talking about having, foundries in orbit. There's already 3D printing in orbit. When you start thinking about that, the aperture starts to open up wide about what could be possible. And I think that's what all of us are working on here to get to.
Yeah, it's amazing, isn't it, when you think about the amount of effort that goes to design satellites so that they can fit into rocket nacelles for the first 5 minutes of their life. Like, what percentage of that manufacturing effort do we and waste and so forth do we put into fitting it into the top of that rocket, when actually, if we could just assemble it in orbit, we save a ton. So I think that's to Max's point about taking out the cost of this. So we have just under 3 minutes to go. So we're right at the end of our panel. So we'll have to be quite snappy in our replies here. I had 1 or 2 quick curly questions, and I thought I would throw those out. Max, I've got one for you, and the language is interesting. So I'll hit you with this. With a full capitalist space station, how will VAST maintain the OST's ethical heritage, working for the benefit and in the interest of all countries? I'm sure you've got a great response for that, because that must be part of CLD.
Well, the first element is that we don't have a sustainable business model without international customers and international collaboration. With just NASA or the US market, we cannot exist. So, if you remove even the ethical or the interest to replicate and enhance what the ISS has done as a tool of global collaboration in an unprecedented way, the incentives are there so that we replicate the same. Personally, I'm born in Belgium. I'm a naturalized citizen, so I obviously love Europe. I've got to, love some of the other countries we might work with, like Japan and others. And, it's so inspiring to have the chance to recreate something like the ISS in terms of global cooperation, personally to me. Beyond the business model, and also to go beyond it in a more sustainable way, because right now this is costing, the ISS is the reputed most expensive single object ever built by human, by some measure, $150 billion plus. And so what if we could do the same level of international collaboration, next level involving more countries, but do it, materially cheaper for all the taxpayers in these countries? So I think, we have a chance at doing at least the same or better, and the incentives are aligned because we need the global marketplace, even in a capitalist framework.
Yeah, it's about to become the most expensive deep ocean reef, I believe, in a few years' time in the Southeastern Pacific Ocean. Okay, one last really quick question, bit of fun. If there was one thing that you'd like to take to space and bring back, what would that be? Chris.
Grapes and then make wine.
Fab. Jeffrey.
Hop and make beer.
Nice. Max.
My kids and wife.
Fantastic.
That was mine. my kids.
Fantastic. Terrific.
I'm sorry to my kids and wife. I should have said.
Yes, priorities, people. Ladies and gentlemen, thank you for being such a terrific audience. I love the questions you sent through. Please thank our panelists who've done such a terrific job putting up with all of us and our Australian English.